Okay, let's see how you're gonna use super heterodyne detector as FM receiver. So the block diagram of receiver of FM is given in this way using super heterodyne receiver. So the signal is received from antenna here. Then there is a pre-selector, which is basically a band pass filter, which is capturing the range 88 MHz to 108 MHz, which is the standard range of FM signal. Then it goes to RF amplifier, which is tuned amplifier, then mixer, local oscillator, standard tuned amplifier, that is IF amplifier. Then there is something called amplitude limiter, what we will see next. Then there is FM demodulator, de-emphasis circuit, audio frequency amplifier, power amplifier, loudspeaker. So we won't be focusing on this stuff, power amplifier and audio frequency amplifier, that is part of analog electronics. This we saw, these all things we saw. Now the only thing we have to see here is amplitude limiter. Okay, so we will see how it is, what is the characteristics of amplitude limiter. Rest everything might be clear to you by now. Okay, let's look at the characteristics. So your IF amplifier characteristics will be like this, which is a standard tuned amplifier, which is centered at FR, which is equal to IF, and that is 10.7 MHz, which is defined by the FCC, and the bandwidth will be 200 kHz. Okay, so this will be the characteristic of IF amplifier. Now let's look at the amplitude limiter. Let's say you have a FM signal like this. So there is high frequency, low frequency, high frequency. This will pass through a channel, and let's say you have a interference at the amplitude of this signal. So high frequency, low frequency, high frequency, but the amplitude is corrupted due to noise. Then if you will pass it through the amplitude limiter, what will happen? You will get the again same signal back. Okay, this is the use of amplitude limiter. So you get your FM signal with proper amplitudes, which is not corrupted by the noise. So within the channel, what happens? Your amplitude gets corrupted, but with amplitude limiter you will be able to recover your FM signal, and which is again passed through a FM demodulator, and from there you can receive MT. But this thing you cannot use in AM, because your AM signal looks like this. If the amplitude gets corrupted due to noise, you can see here, then if you will apply amplitude limiter, you will get a cosine signal. Here the message will be lost, which is not your message signal. Okay, this is your message signal. Yes, so that is why you don't use AL for amplitude modulation. Okay, you only use amplitude limiter for FM. And here you can see the frequency is retained, so that is why you will be able to recover your message signal, but here it is difficult. So okay, so you can say that in AM message signal is stored in the form of peak amplitude variation, which are highly disturbed with noise interference, so that AM transmission is highly noisy and you won't be able to recover the message signal if you use AL. Okay, and in FM you will see information is stored in frequency variation, which is less affected by noise interference. You can see here. So that is why FM transmission is less noisy, AM transmission is highly noisy. Okay.